The idea for QUADRIMA came when we were looking for inspiration for a game from a completely different perspective. Somebody threw in the keyword dog into the brainstorm, which sounded perfect. Everyone loves dogs, there's barely a handful of quadruped protagonist games, and we love a good challenge. So, we decided to try and we started prototyping. A week passed, then another, and another. And slowly we began to realize why there are so few of such games. We had to take a different approach to figure this out, so we put our bets on machine learning. We started with a technique called motion matching, as it requires less data than neural networks. Then, during the first session, we noticed that it wouldn't be easy. The dog was expertly trained, however, constant looking for approval to his caregiver was extremely visible in the animations. Despite that, we created a motion matching prototype in Python and immediately started integrating it into Unreal Engine. Then, we made the first custom asset editor. Good visualization was key, and creating diagrams of different descriptors, which could then be compared to the displayed animation, allowed for some solid feature engineering. We then made the first custom animation nodes. Full integration with the approach to animation in Unreal Engine was crucial to implement in the project. Finally, we managed to activate the first motion matching on the level. The animation still had numerous artifacts, which were deliberately not masked with blending, as this would have made eliminating them much harder. We were working out increasingly more complex motion matching schemes and automatic algorithms, which divided the captured recordings into steps with determined parameters of controls and mutual adjustment. However, we quite quickly reached the limits of this technique. The animations were looking better and better, and yet each adjustment required an increasing amount of work, and enlarging the animation database led to an increase in render time. We decided to start implementing neural networks. We prepared a longer motion capture session, and this time we're better prepared for working with a dog actor. We knew what was natural and comfortable for the dog, while being more aware of what was most valuable in the machine learning process. This allowed us to plan ahead, before we even started the session, and give more precise pointers during it. The results this time were much better than the last, giving us better data for the upcoming development of the project. The primary iterations were anything but easy. We opted for an architecture based on auto-regression and a mode-adaptive mixture of experts. The network easily converged, and then, one by one, we started adding small improvements. After reading dozens of research papers, going through numerous custom ideas, and hundreds of trials and errors, we finally achieved the expected effect, which was an easy-to-use, responsible, and high-quality motion model. To complement the effect, a procedural animation of the dog's tail and ears was added. Dogs express an array of motions this way, so we decided to create a dedicated editor that allows artists to work on the level of movement parameters within the effective physical model. This in turn allowed us to obtain a vast amount of various transitional animations in between the different emotions. After endless hours of work and effort put into creating these systems, we finally arrived at QUADRIMA, which is a direct effect of brainstorming on the most interesting perspectives that our next protagonist can be played from. We are currently working on a game that uses these animation systems, and we cannot wait until you see it at its full potential. Thank you.